So to get comfortable with logarithms, we just want to start by switching back and forth between the two forms. And to just see that this is something we've done before, it's just a new notation. So I'm starting off with log base 3. I've been asked to write that in exponential form, so the base of the exponent is 3. Now keep in mind, logarithms and exponentials are inverses, which mean inputs and outputs switch. So I used to have a 2 on the right-hand side. That 2 is now on the left. I used to have a 9 on the left-hand side, so that 9 is now on the right. So I started off with log base 3 of 9 equals 2. That's not something we're used to saying out loud. It feels kind of weird. But 3 squared equals 9. That is something that hopefully you know. 3 times 3 is 9. These two expressions say the same thing. Log base 3 of 9 equals 2 because 3 squared equals 9. I'm going to take a look at quite a few of these just to get us comfortable with this transformation, this idea. So in number 2, log base 6 of 216 equals 3. Well, my base is 6. My exponent then is 3. And again, we're switching inputs and outputs. So the 216 moves to the right. So 6 cubed, 6 to the 3rd power, is 216. Again, what that means is 6 times 6 times 6 is 216. Let's do some more. 3 is a bit wonky. Log base 7 of 1 equals 0. What the heck does that mean? Well, my base is 7. That's the base of my exponential. My exponent is 0. Well, what is anything to the 0 power? It's just 1. So again, my input becomes my output. My original output is now my input. That's what we mean by inverses. Inputs and outputs switching. Taking a look at number 4 here. Now I have log base 2, so 2 is my base. 16 then is going to go on the far side of the equals. And what power do I raise 2 to in order to get a 16? Oh, 4. So the hope is that we see enough of these logarithms that it becomes really quick to mentally switch between those two forms. Let's look at 2 more. These ones are scary because now there are fractions involved, but we're still going to get some true statements, ones that hopefully we're a bit more comfortable with. Log base 4, oh okay, so 4 is my base. Log base 4 of 1/16 is negative 2. So to flip that around, that means 4 to the negative 2 power. Well, keep in mind that negative is talking about reciprocals, so now we're expecting to have a fraction, and 4 squared is 16. So because of the reciprocal idea, that 16 is in the denominator. Oh look, that's what was here on the left-hand side. 4 to the negative 2 power is 1/16. And last but not least, we have this super ugly one. Log base 9, so 9 is my base, of 27 is 3/2. So 3/2 is my exponent, and 27 is that result. So this was switching from logarithmic form to exponential form. These last two are a bit tricky, but usually we're going to be firmly in the realm of numbers we're comfortable with, things off that common powers table, like 1 and 2 here, and things like 3 will show up quite a bit. So definitely want to be comfortable with those. If you have questions, ask them now before moving on. We're about to do the opposite of this, going from exponential form to logarithmic form, which is going to be the most common way we use logarithms.